All right, so first thing we're going to do is talk about what we're going to make a definition, the definition we're going to use for reflection. Reflection is one of our rigid transformations, so we're going to say reflection. We reflect across a line. A line M. And so we can think of the line as the mirror. We call it the mirror line. Or you'll also hear it called the line of reflection. So our reflection is a rigid transformation. So that means it doesn't change the size or the shape of our whatever our figure is, where a couple of different things happen. So we'll write these things down and then we'll draw a picture about what this is talking about. Any point A on the line is its own image. So we say A equals A prime. So if we think of that line as a mirror, a point that's on the mirror doesn't move. It stays right where it was. Any point B not on the line has its image the same distance away from the line as B. And on the perpendicular bisector of the segment B prime. So let's draw a picture about what we're talking about here. It sounds more complicated than it really is. So here is our mirror line. There's our mirror line. All right. So the first part says that if we have a point on the line, that point A, its image is the same point, A prime. So if our point is on the mirror line, it doesn't move. If we have another point B, so I'm going to draw a triangle here. We'll reflect this triangle. I'm going to do my triangle in blue. I'll make a little triangle, we'll reflect this triangle. So there's point B here. What this is saying is we're going to reflect this point across the line. We go straight towards the mirror. And we decided before that when we say straight towards a line, we mean we make a 90-degree angle. And we go the same distance to the other side of our mirror line as we were in front of it. So there would be B prime, and these segments would be congruent. So however far we go to get to the mirror, our reflection is the same distance on the other side of the mirror. If we look at ourselves in the mirror, our reflection looks like it's the same distance behind the mirror as we are in front. And it's right in front of us, it's not off to the side. So there would be B prime. And if I reflected this other, so if I made this the reflection here, there would be that side of the triangle, and this would reflect down, directly down this way. And then our other point would be there, and our reflection, if I drew everything perfectly, I need to move A prime through it. There's that, A prime. And that's a 90-degree angle. So we reflect at a 90-degree angle to whatever our line is, our mirror line, and we go the same distance to the other side of the mirror to get our image. And we write our reflection with a capital R for reflection. And we say line M of B equals B prime. So the reflection across line M of B equals B prime. That's how we would read that. So that's really the big picture here with reflections. To reflect something, we go straight towards the mirror line, which means we make a 90-degree angle with it, and we go the same distance on either side of the line from our image to our pre-image. All right, questions then? If we know the equation of this line, so if we know the equation of the mirror line, we write, for example, the reflection across the line y equals x. So that would be across the 45-degree line. We could say the reflection across the line y equals 1. We could have any line that we wanted to be our mirror line. The reflection across the line y equals 3x minus 4. So we can reflect across any line we want. And that's what the equations down here are telling us what line we reflect. All right, so let's look at an example using this idea. So we have the point F is 2, 6. We want to reflect it across the line y equals 3. We want the coordinates of the reflection across the line y equals 3 of F. So with these kinds of problems, drawing a picture is going to be helpful. So let's draw our axes and our lines, and then we can figure out this reflection. So it can be difficult to figure out without a drawing. So let's make a little sketch. All right, so there are my x and my y axis. So the first thing that I need to do is graph the line y equals 3. How do I graph my mirror line? What's y equals 3? What does that look like? Well, let's remember y equals mx plus b, and we have y equals 3. So what's our slope here? What would m be if I don't have anything here? 0. What's a line with 0 slope look like? Horizontal. It's a horizontal line. What's my y-intercept? 3. So this line y equals 3 is going to be a horizontal line up here at y equals 3. So there's my mirror line. And here's the point I'm going over 2 and up 6. There's the point 2, 6. There's F. And I want to reflect this point across this line. Well, which direction do I go to find my image? I want to go straight towards the mirror line. So what direction is straight towards the mirror line? Straight down, right? So I'm going to go straight down. So I go straight down, we make a 90-degree angle. My reflection is going to be the opposite side of the mirror line. Well, how far down do I go from the point 2, 6 to y equals 3? 3. Y equals 6 here, and I go to y equals 3 there. So that is 3 units there. So my reflection has to be 3 units on the other side of the line. Well, where do I end up with? Where do I end up? What does y equal if I'm at y equals 3 here and I go 3 more units? Y equals 0. So I go 3 units there. This gets me to y equals 0. And have I moved left or right at all? No. So does the x value change? Nope. So that would be the point 2, 0. That would be f prime. So to find my reflection, I go directly towards the mirror line, and I go the same distance from the mirror line on the other side as I started. So since I was going straight down here, the only thing that changes is the y. Yeah, I'm not moving left or right at all, so the x part doesn't change at all. So we would say, if we were going to write this out, the reflection across the line y equals 3 of f equals 2, 0. All right, questions about what we did there? And we can reflect across any line. We can reflect across y equals 3. We could reflect across the x-axis. We could reflect across the y-axis. We could reflect across any line. And we do the same thing. Find our image by going directly towards the line. Figuring out how far we go on one side. We have to go the same distance on the other side. All right, we can reflect entire figures. We don't have to just reflect points. So if we can reflect a figure, we could say that the reflection across some line of triangle ABC, for example, if we wrote it out, it would be triangle A prime, B prime, C prime. So we'd reflect that entire triangle. So this would be the reflection across the line M, triangle ABC, and we get triangle A prime, B prime, C prime. And the important thing to remember is reflections are rigid transformations. So the reflections don't change the size or the shape of the figure. So what that means is the image and the pre-image are congruent. So the image is congruent to the pre-image. The other way we could say that is the image is congruent to the original. So reflections are rigid motions. So what I want to do next is do a couple of examples that have to do with reflections of entire figures. One, just visualizing a reflection, and then two, we'll reflect a triangle using the ideas that we just talked about. So are we good so far? Okay. So for this one, I'm going to say which could be reflections? So I'm gonna draw a picture with several figures, and I want us to decide which of these could be reflections of each other. These don't necessarily have to be the x-axis or the y-axis. These are just mirror lines. So here's my first figure, and we're pretending that my drawings are all perfect. All right, which figures here could be reflections of each other? 2 and 3? Does everybody agree? 2 and 3 could be reflections? Why are 1 and 2, why wouldn't 1 and 2 be reflections? Couldn't we reflect across this line and get that one? 2 would have to be flipped over to be reflected, right? Because this point would be reflected 1, 2, 3, 4 units. So it'd have to go 1, 2, 3, 4. It would be way down here. So we flip it upside down. So what is 1 and 2? How would we get from 1 to 2? What kind of transformation would that be? A slide, and our fancy word for that is a translation. 1 to 2 is a translation. So 2 to 3, and 1 and 2 is translation. In order for it to be a reflection, this would have to be flipped. How about 1 to 3? Not a reflection. What kind of transformation would that be? Translation. We could slide it just diagonally down that way. All right, we good there? Okay. Let's reflect a triangle. So we're going to say triangle X, Y, Z has vertices at X is -4, 3, Y is at 2, 6, and Z is at 1, -2. We want the vertices of, we're going to do a reflection. So we're going to reflect across the x-axis, triangle XYZ. So let's draw a picture, and we'll reflect these points. So there are my coordinates. Our reflection, our drawing doesn't have to be beautiful and perfect. We just need to be able to get our points. So there's our x-axis, there's our y-axis, and I'm going to plot some points. So X is at -4, 3. Y is at 2, 6. And Z is at 1, -2. So there's my first triangle. I'll do that one in red. So there's that one. And we want to reflect that across the x-axis. So if it helps you to draw the little dotted lines and think about where we're going, that's fine. That's nothing wrong with doing it that way. So here's x. Let's find x prime. So we're reflecting across the x-axis. So which way do we go to find our image? Straight down, right? So I'm going to go straight down here. How far down am I moving from here to the x-axis? 3. That's 3 units. So I need to move another 3 units here. So where, have I moved left or right? No, so what's the x coordinate? If I haven't moved at all from this way? -4. And what's the y coordinate here when I go down below the x-axis 3 units? -3. There's x prime. Let's do z next. Which direction am I going to go to get my image for z? Up. So we have to reflect across the x-axis, so I go up here. How far up am I moving here? 2 units, so I have to go 2 units up here. There's z prime. Have I moved left or right? No? So what's my x coordinate? 1. And if I go up 2, and I go up 2 more, where do I end up? +2. So there's z prime. And now we'll do y to find our image for y. Have to go straight down. And how far down do I go here? 6, so I need to go another 6 down here. So have I moved left or right? No, so what's the first number? 2 and -6. So there are my coordinates, and there would be my reflection triangle. So we think of the mirror as being reflective on both sides. Go either direction. And this would be x. This would be y prime. So x prime is -4, -3. Y prime is 2, -6, and z prime is 1, 2. I think of this as kind of the triangle being kind of attached here and just kind of rotating around it. The way I look at it. But we're going straight towards our mirror line, straight towards the line of reflection, and we have to move the same distance to the line and on the other side of the line to find our image. Questions there? And like I said, we could reflect across any line. Doesn't have to be a horizontal line. We could reflect across a vertical line. So let's think about that for a second. If we were reflecting across a vertical line, and I have this point here, what coordinate's going to change if I'm reflecting across this line? Am I moving up or down? No. So the y coordinate stays the same. The x coordinate is going to change if I reflect across this line. If I reflect across some line like this, then they're both going to change. But we go the same distance either side to reflect across those lines. So we could reflect across any line. We use the same idea. All right. Homework.